Hello everybody, my name is Joseph Temkoff, and I'm going to currently be going over the state of Group 3's GUI for our avionics capstone. As you can see, I've currently got both this started up and our trajectory control simulator started up, because we'll be going over both in the next second, so let's get to it. Hit the run button, our GUI starts up. Now, as you can see, this is the way our GUI's been laid out, as described earlier on our slides. For the sake of time, I'm not going to really go over too much else. I'm just going to show you how the way things work. Now, on this computer, we don't currently have all of the Quanser blocks installed, so I'm not going to be able to show you guys our actual simulation running, but when we turn on our advanced options here, I'm going to put in a little test file. That is just a simple sine wave and scope, and when we hit the start button, that will start up our test simulation and run it. There you go, as it runs. Perfect. And once that's finished, you just hit the stop button. That just ends simulation. Below that we have our set to 0 button. We've kind of gone over how that works. Next we have our control type selector. As you can see, we can switch between the autopilot, the joystick, and the debug. Again, as stated earlier, this will be integrated at a later date, and the button that will be allowing us to switch over to manual control in emergency will probably be going around here inside the GUI. Next we have our drill safety toggle in this position. The safety is currently on. Drill can't drill anything. Safety off. Drill can now drill something. Prevents anybody stupid from sticking their hand in front of it and losing a finger or something. Next, we're going to go to our mission status display. I'll come back to the initial setup planner at the end. The mission status display is currently in an alpha build, and what we intend for it to do is we intend for it to display whatever portion of the mission the helicopter is currently undergoing at that given point. Say it's traveling to the target, getting the target data, drilling into the target, coming back from the target, that kind of thing. Then below that we have our information display. Again, this is in an alpha state, hasn't really been set up yet, but we intend for this to sort of be an all-purpose window that will display, as discussed, our IR, our camera, our different control function, or our different controls and that sort of stuff, all in one convenient little window. Lastly, over on this side, before we get to this, we have our elevation, pitch, and travel data graphs. Again, since we don't have the simulation working on this computer, I can't show you how these fully work, but the data from the scopes inside the simulation will output to the elevation, pitch, and travel data here, so that you can real-time get this without having 4 or 5 different scope tabs open and slowing down your computer. Then we're going to go back to our initial setup plan. Here, I'm going to switch over to the flight during mission just to show you guys what happens, because we haven't set this part up yet, and it will take a little bit. Doesn't work. We shift over to the to mission planner, we hit the initialize, and that starts up our trajectory planner. Now, our trajectory planner that we have here requests 5 points from you, and the angle data, the height data, and the time data from you in order to create 2 splines, an angle data spline and a height data spline for the helicopter to follow. So for the sake of this simulation, I'm going to show you how this works. Let's say we want our helicopter to start at origin, so we would input 0, 0, 0. Then for its next point, we want it to not rotate, but travel up to steady level flight, and do that in the span of 4 seconds. Then have it rotate to 60 degrees, stay at steady level flight, and do that 8 seconds from the previous point. Then have it rotate to 190 degrees. Travel up a little bit to a height of 28. In this case, these values currently are displaying volts. We'll be changing this over to angle in the next build, and have that occur another 8 seconds after the previous one. And then we have it rotate to 340 degrees, go back down to steady level flight, and do that in 10 seconds from the previous point. Now, with all 5 data points input, when you hit the OK button, with the way the build is currently set up, this will generate 4 graphs. This will generate a height data spline, an angle data spline, a height versus time graph, and an angle versus time graph. Nice and simple. We've done this to sort of debug the spline creator setup. At this point, the angle data spline is about at the point where it should be good, but the height data spline is at a point where it should be having a bit of adjustment made to it, as it's not currently entering and exiting all the points at an angle of 0 yet. So that will take a little bit of refinement. That will probably be fixed over the next week or so, and then we will have at least a basic input planner for our helicopter so that we can start testing things out pre-mission. Alright, thanks for your time, everybody.